Okay, so to start off today, we're going to talk about inequalities, solving them algebraically. On Thursday, I believe it was, we solved these mainly graphically, and now we're going to talk about solving them algebraically. So I want you to start off considering this warm-up. Find the domain of y equals 3 times the square root of 5x minus 7 plus 4. Did this back in the first week of school, and you don't need to graph this in order to find this out. In fact, I want you to do it without graphing. Remember that domain means the x values for which the function is defined. So you're thinking about when is the square root going to be defined? So what do we have to think about? Not when x is positive. Yeah, when the radicand, when this inside is positive or what? 0. We can take the square root of positive numbers, and we can take the square root of negative numbers. And we can take the square root of 0, but we cannot take the square root of a negative. So remind yourself to find the domain of a square root function. Set the inside or the radicand greater than or equal to 0. Okay, so if we finish this, we get 5x minus 7 is greater than, or sorry, we already did that part. We get 5x is greater than or equal to 7, and x is greater than or equal to 7/5. So that's your domain as an inequality. What's your domain as an interval?
7/5.
Good. Okay, so because there are domain restrictions on square roots, when you solve inequalities with square roots, you have to pay really close attention to those domain restrictions. So let's look at, let's start looking at these problems. The problems that we look at today, I kind of introduced this phrase to you on Thursday, but they are called one-dimensional inequalities. Do you remember what that meant? Yeah, it's not like y is less than or f of x is less than. Inequalities. Okay, so there's only one variable, and that variable is x, or your independent variable. And when you solve a one-dimensional inequality, your solution is not going to be a shaded region like when we had two-dimensional. It's going to be the set or interval of x values that make the inequality true. Okay, so your answer is going to be the set of x values that make the inequality true. So you're not going to get like x equals 7, and you're also not going to get the point 12, 4. You're going to get a set of x values. Okay, let's start working number 1, and then we'll go back and recap our steps. So we have the square root of x minus 3 is less than or equal to 4. The first thing you're going to do is rewrite this as an equation. The square root of x minus 3 equals 4. And we do this because when you end up having to square both sides and do stuff like that, weird things can happen to your inequality. So we don't want to risk leaving it as an inequality. All right, now let's go ahead and solve this equation. What do? Good. Square both sides. We get x minus 3 equals 16. And x would be equal to 19. Okay? Your next step is going to be to find the domain of your original radical. Just the radical. So you take the part under the radical, the x minus 3, and what do you do with it? Greater than or equal to 0. So the domain of this radical is x is greater than or equal to 3.
So why do we need to find what x equals?
In this step or over here? So that solving this as an equation allows us to find the critical value. It's essentially when the two sides of the inequality cross. It's the x value where they cross. Okay? And then what we're going to do is we're going to post these on a number line and decide which part is our solution. So your next step is to draw yourself in a number line. You're going to put, in order, preferably, 3 and 19. Okay, so 3 represents the beginning of our domain. So I'm not going to plot on the number line yet because I don't know if that 3 is a solution to the inequality yet. But above the number line, bless you, I am going to draw a little arrow. And what that arrow is going to tell me is that's where the domain of my radical is. That's where this radical is defined. So there's no reason to pay attention to numbers less than 3. These can't be solutions to the inequality because they're not even in the domain. I can't even plug them into the radical. So that arrow just kind of guides me. I only need to pay attention to the right side of this number line. All right, let's talk about 19. If I solved this as an equation with an equal sign, I got it equal to 19. So is 19 a solution to the inequality? Yes. Why? Yeah, it says less than or equal to. If it just said less than, I know 19 makes it be equal to, so I would have an open circle. So now there are 2 areas for us to test. Numbers in between 3 and 19, and numbers greater than 19. Okay? So pick a number that we want to test in between 3 and 19. 4, I think, is a good option. 12 is also a good option. Okay? Go with whichever you want. I'm going to go with 4. Okay? So if I plug in 4, the square root of 4 minus 3 is the square root of 1. And I want to know, is that less than or equal to 4?
Yes.
Yeah, that's a true statement. Okay, now test a number bigger than 19. What do you want to try? 20, 23. Okay, any of those will work. Let's try 20. So I have the square root of 20 minus 3, which is 17. And I want to know if that's less than or equal to 4. Well, the square root of 17 has to be bigger than what number? Has to be bigger than 4 because the square root of 16 is 4. So a number bigger than 4 can't be less than 4. So it doesn't matter if you know exactly what it is. You just got to kind of be able to approximate it. Okay, so 20 doesn't work. So I'm shading less than 19. Let's talk about what happens at 3. Is 3 included in the domain?
Yes.
Yeah. So 3 is going to be a closed circle. So my solution is then 3 is less than or equal to x is less than or equal to 19. That's the answer as an inequality. As an interval, bracket 3 to 19.
And if the number works that was greater than 15,
Questions? All right, let's recap our steps real quick. Let's switch to red because I didn't use that yet. Our first step was to rewrite the inequality as an equation. Okay, that's what we did right here. Our next step was to solve that equation for x. What was our third step? Yeah, find the domain of the original radical. So we did that right here. Then we plotted our values on a number line. And finally, we tested values to find our solution. Okay, any questions? Okay. Oh, sorry, yes.
Do you want the answer in like inequality form or interval?
I think it's good practice to write your answer in both forms. On the test later this week, it will specify which form it wants. So practice both ways.
So when we do homework, just do both.
Yeah.
Okay.
Other questions? I'm not turning all the way around so y'all yell out if you need me. Okay. All right, let's solve number 2. Square root of 8x plus 1 is greater than or equal to 7. So what do we do first? Okay, rewrite it as an equation. Go ahead and solve that equation. So we square both sides. Subtract 1. Divide by 8. We get x equals 6. Next step, find the domain of your original radical. 8x plus 1 is what? Greater than or equal to 0. So we get that x is greater than or equal to negative 1/8. What do we do now?
Number.
Yep. Draw your number line.
We put like a 0 in the middle.
You can if it helps you. Good God. But you do not have to.
Okay.
Okay, mark your domain as kind of your guide above your number line. And then we need to test some values. You want to test 0. I think that's a good idea. So if I try x equals 0, I get 0 plus 1, so I get the square root of 1. Is that greater than or equal to 7? No. So 0 didn't work. What should I try bigger than 6? 8, 7, whatever you want to try. So if I try 8, I'm going to have the square root of 8 times 8 is 64, plus 1 is 65. Is that greater than or equal to 7? Yeah, because the square root of 65 has to be above what value? 8. So that does work. Okay, what happens at 6? Is that an open point or closed? Closed because of this equal to right here. And I'm going to shade to the right. So as an inequality, I would have x is greater than or equal to 6. As an interval, I would have 6 with a bracket to infinity. Any questions on that one?
Why would negative 1/8 work?
I'm sorry?
Why would a negative?
So negative 1/8 works as part of your domain. You are allowed to plug it in. But when you plug it in, you're not going to get a value that is greater than 7.
Oh.
So it works as part of the domain, but negative 1/8 is not a solution to the inequality. Okay? Any other questions? Okay, let's look at 3. What's different on 3? Yeah, it's a cube root. So the important thing to remember about a cube root, does it have any domain restrictions? No, there's no domain restrictions. There's no domain restrictions. Okay? It doesn't make the solution to the inequality all real numbers. It just says that the domain is all real numbers. So what that means, because we have a domain with no restrictions, is that we can just solve this inequality as normal. Okay? So what would we do? Subtract the 7. Cube both sides. So we get x minus 6 is greater than negative 27.
Why don't we set it equal to?
Okay, so you don't have to write this one as an equation because you can solve this as an inequality. The difference between cube roots and square roots is when you start squaring sides, you're essentially multiplying by a negative, and it starts messing with your sign. So it's a lot safer to do it as an equation. With a cube root, if you cube something, if it was positive, it stays positive. If it was negative, it stays negative. So the signs don't get messed up. Okay? So we get that x is greater than negative 21. Now, that all being said, I would still double check this. So let's say I plug in 0. Is 0 greater than negative 21? Yeah? What might be even easier than plugging in 0? How about 6? Yeah? 6 minus 6 is 0. The cube root of 0 is 0. And 0 plus 7 is greater than 4. So this does work. So that's my answer as an inequality. And then as an interval, it'd be negative 21 to infinity. Okay? All right, I want you to try number 4 on your own. What are you going to have to do first before you square anything? Good. Make sure you isolate your radical first. So I'm going to give you a minute or two to work number 4. Feel free to check in with the person sitting next to you. I'm going to start working the beginning part up here, but you keep working on yours. All right, so hopefully everyone was able to get to about here. You know which way your domain goes. You know that you've got 16 as a critical value, but it's not a solution. Any questions getting to this step?
Oh, so if it's a cube root, you don't find a critical value.
Right, if it's a cube root, you can just go ahead and solve the inequality as you normally would. If it's a square root, you need to go back and follow the steps we talked about at the beginning. Okay? All right, so I need to test points between 7 and 16 and greater than 16. So what could I try between 7 and 16? Yeah, I think 8's a great choice. If I plug in 8, I get the square root of 1 plus 9. Is that less than 12? Yeah. So 8 works. What could I plug in greater than 16? 20 what? 23. So the square root of 23 minus 7 is 16 plus 9. I want to know if that is less than 12. Yeah, because this is 4 plus 9, which is 13, which is not less than 12. So 23 doesn't work, so I shade to the left of 16. What happens at 7? Stops with an open or a closed? Closed. Because 7 is part of your domain. So your final answer here is 7 to 16 as an interval. Or 7 is less than or equal to x is less than 16 as an inequality. Yes, ma'am. It's not that it's just. But thank you. Do y'all want the fan on? If y'all are hot, we can turn the fan on.
Yeah.
Yeah, go ahead. But Colin, will you turn it on for us? Just plug it in. Yeah.
If when we plugged in 23, if it works, how would you write that as an inequality?
If you plugged in 23 and it worked, something went wrong. Because you shouldn't have just like a gap of a solution. Like, you wouldn't have a gap in your solution region. Because picture what this looks like. This is a square root function, right? And then this is the line y equals 12. So picture that as your line y equals 12. You could never just have like a gap in your solution. It's always going to like be part of it above and part below. Or you could have the whole thing above or the whole thing below. But you could never just skip if you think about what the graph would look like.
So once you figured out that 8 was right, you really didn't need to test 23?
I mean, you still should, because if you tested it and got that it worked, then you got to go back and check where you messed up.
Okay.
Okay? All right, let's do number 5. Even though this has two radicals, we're going to work it the same way. So we're going to start by rewriting as an equation. All right, and then what are we going to do? Square both sides. Solve for x. We get x equals 4. Okay, what do we do next, do you think? Yeah, we're going to have to check in the domain. We're going to have to check the domains of both of these. So the first one would be 3x minus 1 is greater than or equal to 0. So x is greater than or equal to 1/3. And the other domain is x plus 7 is greater than or equal to 0. So x is greater than or equal to -7. Now, any value in our solution, any x value in our solution, has to be a part of both domains. Does that make sense? I can't have an x value that's a solution that's only part of one of the domains, because I have to be able to plug the x value into both of them. So think about this. If I have x greater than or equal to 1/3 and x greater than or equal to -7, which one is more restrictive?
1/3.
Yeah, the greater than or equal to 1/3, right? Because there are numbers bigger than -7 that don't fall in this domain. 0 is a part of this domain, but not this one. So when we plot our number line, the only domain we're concerned with is the greater than or equal to 1/3. Does that make sense why I'm only choosing that one? It's okay to say no. No? Okay. So let's plot both of these domains. I'm going to go ahead and add -7 here. So one of my domains goes from -7 to infinity, and one goes from 1/3 to infinity. Okay. Any answer that I get, any final solution that I get, those x values have to be able to be plugged in to either domain, to either side. So if I tried to say that 0 was a solution, well, if I plug in 0 on this left side, is it part of the domain? Am I allowed to do that? No. So that means the only domain I'm really considering for this problem is where they start overlapping. So it's this part. You look for the more restrictive domain. Okay? So that means I only need to test points in between 1/3 and 4 and in between 4. Now, say you don't remember this and you test points back here, you're going to figure it out because you're going to get the square root of -1, which you can't do. Okay? All right, so why don't I try, say, +1 here? How about that? If I plug in x equals 1, I'm going to get the square root of, let's see, 3 times 1 is 3 minus 1 is 2. I want to know if the square root of 2 is greater than the square root of 8. Is that true? No. So 1 doesn't work. What do you want to try next? 5. The square root of 3 times 5 is 15, so let's say the square root of 14. I want to know if that's greater than the square root of 12. Yeah. So 5 works. Is 4 a solution?
Yes.
No, why not? Good, that's the solution to the equation. So that's when they are equal to each other. We just want greater than, not equal to. So 4 is open, shade to the right.
Greater than or equal to, would 4 be a solution?
Yes, if it were greater than or equal to, 4 would be a solution. So I get 4 to infinity, or x is greater than 4. Okay, try number 6 for me. That's negative 2 plus the square root of 9 minus 5x, all under the radical, and then greater than or equal to 6. Okay, I want you to keep solving it on your paper. I'm going to start solving it up here, but don't look up till you're ready to start checking. All right, were you able to get to this point? Solve your equation, get x equals negative 11, and get that your domain is less than or equal to 9/5. Do you remember to flip your sign? Good. All right, we need to test some points now. What should we try between negative 11 and 9/5? I'm going to try 0. You can try whatever you'd like. I'm going to try 0. So negative 2 plus the square root of 9. I want to know if that's greater than or equal to 6. What's the square root of 9? 3. So negative 2 plus 3, is that greater than or equal to 6? No. All right, what if we try negative 12? I get negative 2 plus the square root of 9. What's negative 12 times negative 5? Positive 60, right? Now I don't know if that's greater than or equal to 6. So I want to know if the square root of 69, can I add 2 to both sides? Is greater than or equal to 8. Yeah. Because the square root of 64 is 8, so anything bigger is going to be bigger than 8. So that works. So we shade left. Why is 11 included? Good, because of that greater than or equal to. So negative infinity to negative 11 with a bracket. Or x is less than or equal to negative 11. Okay, one more. It's a short one. 8 plus the square root of 2x is less than or equal to 5. So I get 8 plus the square root of 2x equals 5. Oops, not 25. 2x equals 5. What would I do first? Yeah, isolate the radical by subtracting 8. And what do we get?
Wait, can you not do that?
Yeah, can you take the square root of something and get negative 3?
No, solution.
No, so this is no solution.
That's tricky.
If you were to keep going, because you could keep going, you could square both sides, you'd get 9/2. Okay? What you'd end up with, listen, what you'd end up with is on your number line, you'd end up with this random solution in the middle of stuff that doesn't work. It wouldn't work on either side. So that would tell you, oh, I got to go back and double check something. It didn't work. Okay? On your homework, you can cross off numbers 11 and 12. On your homework, you can cross off numbers 11 and 12.